Welcome to The Explainer. Today, we're going to demystify the hidden world of network connectivity. We're going to pull back the curtain on what's really happening from the moment you hit connect to that second you're finally online.
It really does feel like magic, doesn't it? 1 second you're off the grid, and the next you're streaming, you're browsing, you're connected to everything. But, it's not magic. It's actually this super fast, really fascinating conversation happening behind the scenes. So let's break down exactly what your device is saying and who it's talking to.
Okay, so before any conversation can happen, everybody needs to agree on the rules of how to talk. And in networking, for devices all over the planet to communicate with each other, they all have to follow a universal blueprint. They have to speak the same language.
And that blueprint, that's called the OSI model. Probably the easiest way to think about it is like a 7-story office building. Each floor has a very, very specific job to do. And data? Well, it has to travel up and down through every single floor, with each one adding or removing a little bit of information until it's ready to go.
So if you look at this journey, it all starts way down at the bottom, layer 1. That's the physical layer. We're talking the actual hardware, the cables, the Wi-Fi signals. Then you go all the way up to the top, to layer 7, the application layer. That's the stuff you actually see and interact with, like your web browser. And in between, you've got these crucial jobs being done. Like, the network layer is basically the GPS for your data, handling addresses and routing. And the transport layer? It's like quality control, making sure all your data arrives safely and in the right order. It's a whole digital assembly line.
All right, so now that we know the rulebook for communication, let's talk about identity. Because every single device on a network needs its own unique identity. It's just like how every house on a street needs its own address so the mail actually gets to the right place.
And in the digital world, that identity is its IP address. I mean, without it, your router wouldn't have a clue whether to send that cat video to your phone or your laptop. It is the absolute fundamental piece of information that directs all traffic across the internet.
Back in the early days of the internet, the way they handed out these addresses was pretty rigid. They were all grouped into these fixed classes. And, well, it seemed like a good idea at the time, but it came with a huge, huge problem.
Just take a look here. You had really limited choices. Class A was from massive organizations, giving them over 16 million addresses each, whether they needed them or not. And then on the other end of the spectrum, you had Class C for tiny networks, giving them only 256 addresses. There was just no good in between.
So here's the kicker. If a company needed, say, 500 addresses, they were forced to take a Class B block, which came with over 65,000 addresses. Just think about that. Almost all of them went to waste. This incredible inefficiency meant we started burning through our available IP addresses way, way faster than anyone ever expected.
So, to fix this mess, a much smarter system was created. It's called classless interdomain routing, or what everyone just calls CIDR. And what CIDR did was brilliant. It just got rid of those rigid classes and let network admins create custom-sized networks, tailored exactly to what they needed. And this just perfectly illustrates the power of CIDR. See that little slash number, like a /24 or a /16? That little number defines exactly how many addresses are in the network. So now, if you need about 500 addresses, a /23 network is perfect. Need just a handful? You can do that too. No more waste. It was a total game changer.
But here's the thing. Even with a smart system like CIDR, the original address book, IPv4, only had about 4 billion addresses. That sounds like a lot, right? But in a world of smartphones, smartwatches, smart everything, it's just not enough. And that's exactly why the world is moving over to IPv6. It provides a pool of addresses so massive, it's hard to even wrap your head around. We're talking enough for trillions of devices for the foreseeable future.
Okay, so we get what an IP address is and why it's so important. But how does your phone actually get one? When you connect to the Wi-Fi at a coffee shop, where does that address come from?
It's actually a lot simpler than you might think. The moment your device joins the network, it basically just shouts out into the digital void. It broadcasts a simple request to anyone that's listening, saying, "Hey, I'm new here, and I need an IP address to get online."
And guess what? There is something listening. On pretty much every network, there's a designated server called a DHCP server. DHCP stands for Dynamic Host Configuration Protocol. But all you need to know is that its one and only job is to listen for those requests, check its list of available addresses, and hand one out to the new device.
This whole conversation happens in 4 lightning-fast steps, and people usually remember it with the acronym DORA.
Your device discovers a server. The server makes an offer of an IP address. Your device formally requests that specific address, and finally, the server acknowledges the request, and the deal is done. This whole thing happens in milliseconds. It's that fast.
Now, DHCP is actually pretty flexible in how it does this. For guest devices, like at that coffee shop, it can use dynamic allocation. It just hands out a temporary address that goes back into the pool when you leave. For your trusted devices at home, it can use automatic allocation, where it tries to give your laptop the same IP it had yesterday, just to keep things consistent. But for the really critical stuff, like a network printer or a big server, an administrator will use manual allocation, also called a static IP. They permanently reserve one specific IP that will never, ever change.
All right, so for our final section, let's bring it all home. Let's connect all the dots. We've gone over the rules, the addresses, the assignment process. Now let's trace that complete journey your device takes from being totally offline to connected to the world. So to put it all together, you join a network. Immediately, your device kicks off that DORA process to get its unique IP address from the DHCP server. As soon as it has that address, bam, it's officially on the network. And from that moment on, every single packet of information you send or receive is built and processed following the rules of that 7-layer OSI model we talked about at the very beginning.
And there you have it. What feels like a simple tap on your screen is actually this incredibly complex and beautiful dance of protocols and addressing systems. The magic is really just some brilliant, brilliant engineering. You know, when you understand how it all works, it really makes you wonder, what's the next great challenge for keeping our hyper-connected world running? Thanks for watching.